Okay, so let's just get right into it. For anyone who's ever worked with JavaScript, you know the big limitation, right? The single thread. It's this one-lane highway that has to handle absolutely everything, from your UI animations to heavy-duty data processing. And in a mobile app, well, that's a perfect recipe for a frozen screen. But what if there was a way to break that rule? Today, we're going to break down exactly how React Native pulls this off, using a superpowered engine called Hermes to unlock true parallel processing.
Here's the plan. First, we'll dig into why Hermes is the default engine for React Native now. Then, we'll tackle that single-thread problem head-on. After that, we get to the really good stuff, how we can unlock actual parallelism. We'll walk through the entire workflow, step by step. And finally, we'll wrap up with an honest look at the benefits versus the costs.
All right, let's kick things off with the star of our show, Hermes. Now, if you've spun up a new React Native project anytime recently, you're already using it, maybe without even realizing it. Since version 0.70, it's been the default. So let's explore why this one decision was such a massive game changer for app performance.
Look, don't just take my word for it. Let's look at the numbers. This chart zeroes in on one of the most critical metrics for any app, time to interactive, or TTI. It's that gap between tapping the icon and actually being able to use the app. And as you can see, compared to the old engine, Hermes just blows it out of the water, cutting that wait time down significantly. That's not just some abstract number, that's the real-world difference between an app feeling snappy and an app feeling slow.
So what is Hermes anyway? Well, think of it like a custom-tuned engine built specifically for the React Native racetrack. And its secret sauce? It's something called ahead of time, or AOT compilation. Here's a good way to picture it. Most JavaScript engines are like a chef who starts prepping your meal only after you've ordered. Hermes is like a meal prep service. It does all the hard work, the chopping, the measuring, beforehand, during the build process. So when you launch the app, the code is already in this super optimized, ready-to-go format. So when you add all that up, what do you get? A huge win, that's what. We're talking faster startup times, less memory being eaten up, and even a smaller app download from the store. Any one of those is a nice improvement, but together, they create a way better user experience. And because it's bundled right in with React Native, you get all this performance right out of the box.
Okay, so now that we've seen the solution, let's back up and really dig into the problem Hermes helps to solve. This is the classic headache, the bottleneck that has been a part of JavaScript UI development forever, the single thread.
It all boils down to this one simple but really profound constraint. By design, all of your JavaScript code, every calculation, every state update, every animation, it all has to get in a single file line and run one after another.
So that raises the obvious question, right? What happens when you need to do something that's actually, difficult, like processing a huge chunk of data or running a complex calculation? What happens to the user while that one task is hogging the entire line?
Yeah, this is what happens. Total gridlock. The user interface just locks up completely. While that main thread is busy doing heavy lifting, it literally can't do anything else. Your smooth animations grind to a halt, taps do nothing, and the user is just left staring at a frozen screen, probably thinking your app is broken.
But this is where things get really clever. This is how React Native and Hermes let us escape from that single-thread prison. And the breakthrough really comes from two key ideas: worklets and running multiple runtimes.
Okay, first concept, the worklet. Let's say you have a really complicated task. A worklet is like taking all the instructions and all the pieces for that one task and putting them into their own separate self-contained box. It's a little chunk of JavaScript code that has everything it needs to run all by itself. You can then just hand that box to someone else to deal with, freeing you up to do other things.
So you've handed off the box, but to who? This is the magic. A worker thread doesn't just borrow the main engine. No, it spins up a completely new, totally separate, totally isolated instance of the Hermes engine. It gets its own memory, its own environment, its own little world to work in.
So here's the big takeaway. This is the paradigm shift. We go from a world with one engine stuck on one thread to a world with multiple, isolated Hermes engines all running in parallel on different threads. We're finally taking full advantage of all those cores in a modern phone CPU.
Okay, so that's the theory. But what does this actually look like in practice? Let's visualize the entire workflow, from beginning to end, to see how all these pieces really fit together. The whole thing really just breaks down into 4 main steps. First, the main thread delegates the heavy work, packaging it into a worklet. Second, a worker thread executes that worklet in its own private Hermes instance.
Third, the worker communicates the result back as a message. And finally, the main thread receives that result whenever it's ready, without ever being blocked.
All right, let's see this in motion. On the left, we've got our main UI thread. Its job is to keep the app feeling fast and responsive. And on the right, we have a worker thread, just waiting for something to do.
So the process starts when the main thread hits a big task. But instead of getting bogged down, it just bundles that job up into a worklet and fires it over to the worker thread.
And this right here, this is the whole point. The main thread is now totally free. It's off handling your taps, your scrolls, keeping those animations buttery smooth. Meanwhile, the worker thread spins up its own brand new Hermes runtime and starts executing that worklet's code completely on its own.
Now we have to pause here for a second, because this is a really critical detail. These Hermes runtimes are completely isolated. They have no shared memory. One can't just reach into the other and grab a variable. And that's a good thing. It prevents a whole category of nasty bugs. Instead, they communicate by passing messages back and forth, kind of like sending a letter or a text.
So once the worker thread is finished with its task, it just bundles up the result into a message and sends it back. The main UI thread gets this message asynchronously, meaning it just picks it up when it has a free moment, and can then update the UI, all without ever having frozen in the first place. So this whole architecture is obviously incredibly powerful, and it is. But like pretty much any big engineering decision, it's not a free lunch. So let's get the complete picture by looking at the benefits versus the trade-offs. On the one hand, the benefit is massive. Your app stays responsive, it feels smooth, you're actually using all the power of a modern multi-core phone. But on the flip side, there are costs. Spinning up whole new JavaScript engines takes more memory. There's no way around that. And since these threads can't talk directly, you, the developer, have to be more careful about how you pass data back and forth. It adds a bit of complexity for sure, but for the right kind of problem, that payoff and user experience is absolutely worth it.
So there you have it. React Native, powered by Hermes, has fundamentally changed the game. The old chains of the single JavaScript thread have been broken, and that opens the door to a whole new class of more powerful, more responsive apps. This isn't just a small step, it's a huge architectural leap forward, which of course leads to the really exciting question, now that we can do things like on-device machine learning or real-time data analysis without freezing our apps, what are we going to build next?